Now let's introduce the repository pattern to separate our controller code from our database code so that we can test those data access requests in a bit better way. The purpose of the repository pattern is to not have to hard code the actual database itself into these controllers. We'd like to have something that's going to be a testable surface for getting at this data. And the idea would be an object that we can request the data from, but also that we could mock up when we're going to write tests. That's going to come in the form of a repository. So we're going to start by creating a new class called the world repository. It does make it sound a little grander than it probably is. And here we're just going to expose out methods that represent the API that we're going to be looking for. So let's do public enumerable trip get all trips. We might have other interfaces like IEnumerable, get all trips with stops, right? A way to, for certain users that need them, to be able to get at the trips with the stops pre-filled in. Pretty easy. But before we can actually make these work, we're going to need that context object. So just like in the other places we've used constructor injection, we'll go ahead and include the context object here and store it as a local field. Then this should be as simple as just saying returning context.trips.orderBy. And what's interesting about this is the idea of uniformity, that we're going to be hiding inside the repository some knowledge of what we want. Now, there's some different philosophies around this. Some people build repositories that you can then query against what the repository returns and those sorts of things. My philosophy is more that this is a surface area for the kind of data operations you want to be doing, and getting all trips is going to know about how it's being ordered. And we'll do the same thing here with get all trips with stops, but we're going to include, I'm going to break this into multiple lines so it's a little easier to see. But we're going to make a call that's called include to tell it to specify which navigable properties to use. So include is actually in another namespace, system.data.entity, so we'll bring that in. And we'll see that what it wants is a link expression to describe that. So trip.stops. This is going to tell it to go ahead and get the trips, but include the stops as well. So now we have this repository object that represents the first couple of calls. We're going to be adding to this as we continue to fill out the rest of the app. But we want to be able to mock this or create an interface for it so that it can be tested against. So I'm going to use refactoring to extract an interface. Control period, pop up this menu, and it'll bring us this little dialog to extract an interface. It assumes we want iWorld repository and that it wants both of these public members on that. And all that is correct, so we'll say OK. Like I talked about before, the refactoring is a little skewed right now that it's still creating it in the root of the project, so I'm just going to move it up to model where it belongs. And notice that it added this interface as a class that implements that interface for us. So we now have a repository. We'd like to be able to use it directly in our app controller. And in fact, for us, we're going to replace the context itself with the repository. And let's rename this to repository by F2 to rename. I'll do all those fix-ups. But instead of returning a repository, we're going to actually use the interface instead. Again, so that later if we want to test the controller, we could pass in a fake repository that returns some mock data that we could test against. And instead of our trips getting this by doing the query, we're just going to change this to those calls. Get all trips, and then we're passing them in there. The last step, of course, is to register iWorld repository so this will actually work. And that's done in startup. Like we've done with the others, we're going to use services. But we're going to use add scope this time because the construction of the repository and possibly the context, we'd like that to only happen once per request. And scope is going to allow us to do that. So we'll add the world repository based on the interface. And in that case, our new app controller should actually return that same set of trip data, but through the repository now. Since we're passing it to the view, let's go ahead and complete that view as well, so we can see this work beginning to end. Down here in the map, Let's go ahead and add a for each trip in trips. Let's go ahead and just create a quick unordered list and then fill this in with li at trip.name. Now notice I'm not getting IntelliSense here on the trip name, and that's because we're not yet using a model. A model is a way to strongly type the view here so we know what data is being passed in. Our app controller is returning here an IEnumerable list of trips, so that's what we can do here, say at model IEnumerable trip. Now because the namespacing doesn't have the world models already included in them, we have to go ahead and fully qualify trip. But by using this as at model, we're going to tell it that we have a member in the view called model, uppercase, that represents the data that's being passed down. That is the model that's being passed from the controller, and we're just telling it to strongly type it to this type. So then we can come over here and say for each trip in the model, go ahead and say trip. And then once we have that strongly typed, we're going to get IntelliSense here in the Razor file. So we'll do name, and then we'll do a quick at trip created to short date string, just so we have that listed on the page. So now we've introduced the repository and we're showing it being used in the view. Let's see if it actually works. And there are our trips. So we've shown how to create the database, see the database, get data out of the database, and now display it in a view by using it as the model from the controller. So we've kind of come this full circle of the kind of data we really want to be seeing. But what if things go wrong? What if the data isn't good? What if the query isn't good? What if saving the data is failing? Next, show you how logging works, so at least you have a way to store that information.